Okay, let's take a look at sample exam 2, Chem 11, number 16. This question gives you a scenario and asks you to explain why they're correct or why they're wrong. So the scenario is that you and your friend go to a gas station to fill up your tires with air. And when you're filling it up, your friend said that both the pressure and the volume of the gas in the tires is going up. So that means P goes up and V also goes up along with it. And so there's a disagreement here because according to Boyle's law, when P goes up, V is supposed to go down. So that means there's a problem with the observation that we have, which is both P and V are going up. So explain why there's this contradiction. Now remember that in Boyle's law, in order for Boyle's law to be true, not only do these two parameters have to have that relationship, but also, more importantly, the other two parameters, T and number of moles, have to be constant. And so that's the part that's not being discussed in this question. So if you think about temperature and number of moles being constant, that clearly is not the condition of these tires when you're filling it up. Because when you're filling it up with air, you're putting in gas into here, right? So originally you have this much gas, for example. Now you have a lot more gas in there, a lot more gas particle, okay? So basically your N, if you have N1 and N2 here, your N2 is greater than N1, okay? Now the temperature might be the same when you're going, let's say the temperature 1 and temperature 2 are equal to each other, but clearly the number of moles is not equal. So if you look at your ideal gas equation, PV over NT equals R, and then you write it for two different conditions, so like that. Now if temperature 1 and temperature 2 are equal, you can cancel them out from the equation, but what you're left with is then P1 V1 over N1 equals to P2 V2 over N2. So then the question is it possible for pressure and volume both to increase in this condition with the expression still equal to a constant? And the answer is of course yes, because as both of these numerator components are increasing, the denominator also increase along with it, right? So if both of them increase a total of a factor of 10, the number of moles could increase by a factor of 10 and you're still going to get a constant as a result. So this increase that we observe in pressure and volume doesn't really violate ideal gas equation. It violates Boyle's law because the condition of Boyle's law is not actually happening, right? Because in order for Boyle's law to be true, the number of moles has to be constant. So when the person who says that this has to follow Boyle's law, there's a misunderstanding because Boyle's law is not happening right now because Boyle's law requires number of moles to be constant, okay?